Okay. Yeah. Hi. Okay. So today we are solving the differential equation dy dx equals minus 2 minus y plus y square, where my y1 equals 2. So my y1 is the particular solution. It will be always be given in the differential equation. It will be given. So we know that dy dx equals minus 2 minus y plus y square is more or less like a quadratic equation. It's like a quadratic equation in a form ax ax square plus bx plus c. Okay, so our differential equation is in the form minus 2 minus y plus y square. It's like more or less a quadratic. So we term this differential equation as a riccati equation. So riccati equation is always in a form as a quadratic. So we can write riccati equation in the form y prime equals p of x plus q of x y plus r of x y square. So note that this is the form of a riccati equation. This is the form for a riccati equation. So riccati equation can be written in this form. So we write the original question, to satisfy this form. So we do comparison. So by comparing the coefficient of p of x, p of x and q of x and r of x for this, we know that p of x could be or would be -2. My q of x2 would be -1. My r of x is 1. My r of x. So my r of x is 1. Hence, for riccati equation, this is the shortcut for deriving or converting this whole equation into linear form. This is the equation: z prime equals minus qx plus 2y1 times rx bracket close multiplying z minus rx. Hence, we made a substitution by substituting the values of p of x, q of x, and r of x. So my z prime equals minus bracket open -1, which is the q of x, which is the -1, q of x -1 plus 2 multiplying y1. The y1 is given, which is 2 times 2 multiplying r of x, and r of x is 1 minus r of x, and the r of x 2 is 1. And simplifying, we are getting z prime equals minus 3z minus 1. So we can see this red line shows that this equation is in a form linear. So more or less we can write this in the form linear. So we can bring my 3z to the left hand side so that we maintain the -1 here. So we write the equation in the form this, in the form y prime plus p of xy equals q of x. So this is the linearity. That's the linear form. Okay, so upon doing this, we also try to compare the coefficient. So from the question or from the formula or the form, the linear form, I know that my p of x is equal to 3. My q of x equals -1 from here. And after the linear form, we try to find the integral factor. So this is the integral factor. So my integral factor is e exponent integral of p of x dx. And by comparing the coefficient of y, which is p of x, which is 3. We know that my p of x is 3 from this equation. Know that my p of x is 3. We are using y prime and y, but then the question we had z prime plus 3z minus 1. So we can more or less replace my equation in the form p of x z equals q of x. So that to avoid confusion, you can write this linearity in a form this. So this is my z prime, this is my p of x, this is my z, this is my q. So it's the same thing. Okay, so finding my integral factor, I know that my p of x is 3 by comparison. So I'll integrate. I know that when I find the integral of 3 dx, you are going to get 3x, because an integral of a constant is you add x to the constant, which is 3x. So you are getting e exponent 3x. So this is my integral factor. This is my integral factor. After finding the integral factor, we try to multiply the integral factor through the whole equation. That's the linear form, the one we wrote earlier on, the linear form. So upon multiplying the integral factor through the linear form, this we are getting my e exponent 3x multiplying by z prime, this z prime plus my e exponent 3x multiplying 3z equals minus 1 multiplying e exponent 3x. So we are done multiplying through by the integral factor. So we try to simplify. So we know that this is more or less a product rule. A product rule. So the whole of this can be written as this, because you know that when we hold z constant, we are getting this z. Then when we differentiate 3 exponent e exponent x, we are getting 3 e exponent 3x. At the same time, when we hold e exponent 3x constant, then we differentiate z, we are getting z prime. So this is a product of the z and the e exponent 3x. So partially, this is a partial form of this. It's equal to minus e exponent 3x. Hence, you know that my integral of d dx of this, the partial of this, you know that the integral will cancel the d dx, remaining my z e exponent 3x. And remember, when we integrate a function, more like this is an exponential function, we maintain the function which is e exponent 3x, then we differentiate the exponent which is 3. We differentiate 3, we are going to 3x, we are going to get 3. Then we divide this by 3. That's how we had this. Then we add our constant c. So we are trying to make z the subject. We divide both sides by e exponent 3x. We divide the whole of this equation by e exponent 3x. So now my z equals, I know that my e exponent 3x will cancel or take away the e exponent 3x plus more or less this c over e exponent 3x can be written as c e exponent minus 3x. Hence, but in riccati's equation, after finding the solution for the z, remember not to forget this expression. So we make a substitution by using this expression. So always keep this expression in mind. My y equals y1 plus 1 over z. Okay, so after getting my z from the equation, wherever I will see z, I'll replace minus 1 over 3 plus CE exponent minus 3x. Then wherever I will see my y1, that's the particular solution that was given in the question. It was 2. So I will just add it. So you are getting 1 over the z. So this is the z. Thank you very much.